Good evening, ladies and gentlemen. Thank you for coming to our event or joining us via live stream to support Friends of Science Society. My name is Michelle Sterling, and I'm the Communications Manager for Friends of Science Society. At Friends of Science Society, we stand for open, civil debate on climate science and energy topics, and full cost-benefit analysis before implementation of net zero propositions. Yeah? Yeah. We're a small volunteer-run nonprofit society. We're now in our 23rd year of operation. Tonight, our special guest speaker, Dr. Joseph Fournier, senior scientist and rancher, will enlighten us about Canadian farm practices and how net zero ideology impacts food production and food prices. Our theme tonight is food prices, farming, and net zero ideology. Most of you have noticed that food prices continue to rise. Even though the consumer carbon tax has been canceled, the burden has not left the agricultural sector or the food production sector. As the food professor, Dr. Sylvain Charlebois, has pointed out recently, the industrial carbon tax is still in place, and that affects food production, transportation, and the price you pay at the store. So many climate activists are adamant that farming practices need improvement without knowing anything about the many miraculous improvements that are already in place. Government officials have been pressured by climate activist groups to force farmers to reduce or phase out fertilizer use. But have they thought of the implications of that, of a lower crop yield in a hungry world? Do they even know the secret of crop abundance that helps farmers feed the world? Are cows the new coal? And if you stop eating steak, does that save the planet? Dr. Joseph Fournier, senior scientist and rancher, will provide some insights on these issues tonight. So now let me give you a bit of background about our guest speaker. Dr. Joseph Fournier is an accomplished executive and senior scientist with a 15-year track record in the oil sands, power generation, environmental science, and agricultural industries, both in Canada and the US. His career has afforded him an exposure to a diverse range of exciting technological development projects where he enjoyed fulfilling leadership roles with numerous capital projects, each more than $100 million. Dr. Fournier's formal graduate training was in chemical physics with a focus on solid-state electrochemistry specific to hydrogen fuel cells and battery technologies. And his undergraduate training was in physics and environmental chemistry. Currently, Dr. Fournier lives east of Calgary near the village of Rocky Ford, where he and his family own and operate a ranch. Dr. Fournier's professional engagements include freelance journalism, and he's written over 70 articles in the past 2 years on a range of topics in the space of energy, environment, and climate science. Dr. Fournier also has a wonderful Substack, by the way, so you can find that online under his name. So with no more ado, please welcome Dr. Joseph Fournier.
What is net zero? It's just another moniker. A lot of them we've floating around in the last 5 years. It's synonymous with energy transition. The basic idea is, well, doesn't need too much explaining, that there's right around the corner. Tomorrow, next month, next year, there's going to be a point where humanity's going to suddenly find a whole new form of energy. We call it a sustainable, clean energy. It seems to be wind and solar, biofuels, but the net zero and energy transition are basically synonymous. Net zero is like you're going to have as many emission sources as you're going to have emission sinks, so they call it net zero. But what this plot here represents for me is a query I ran a couple years ago where I was like, when did these monikers first come up? And so I ran a Google trend stat, and energy transition, Great Reset, Build Back Better, they all popped up right around shortly after Joseph Biden became president of the United States, 2021. There was a little bit of reference back in 2015, back at a G7 conference, 2015 G7 conference just before the Paris Accord, where our former Prime Minister, Stephen Harper, sort of agreed to the rest of the idea of by 2050 we're going to phase out hydrocarbons, and it was just like, well, I guess everybody else is saying it's doable, sounds good. I'll nod my head and shake hands over it, but it didn't become, legislated until after the Paris Accord and the change of Prime Minister came on board. The point here, that why I wanted to include this is the motive for these terminologies that the U.S. administration came up with. They invented these terms together with the World Economic Forum. These slides can be available for you to look at. There's hyperlinks, so I've got references here. They very clearly say the motive was the Great Reset. There's an opportunity to build back better a utopian future where we don't use hydrocarbons, and the future will be a net zero. But the idea is we want to transform everything, capitalism and food. Food production is particularly a key component of net zero and this idea. So that's where we're going to be leading in the rest of this talk today. There's a slide from a company, a research consultancy firm called Thunderset Energy. Here, as you can see, is a plot going back well over to 1900. The vertical axis is primary energy costs, so like coal, oil, natural gas, as a percent of GDP. And you can see the 1970s oil crisis, financial crisis. I just came up with the term lockdown crisis, right? Whatever you want to call it, right? It was a combination of things, obviously, massive quantitative easing, then the war in Ukraine, massive sanctions against Russia, the list goes on. But it's the one thing that when I look at this entire topic of net zero energy transition, to me, it's all about inflation. So it's pretty clear that's what's going on. According to Thunderset, you can expect it's not going away. And we're told this time and again from the likes of Mark Carney, who came out of the World Economic Forum, Barack Obama, they've all openly admitted that short-term pain, folks, long-term gain. Bear with us. This too shall end. That's what we're promised. So this slide here, I wanted to include this one. This is from Canada's Food Price Report. I think Dalhousie University spearheads this every year or every couple of years. A breakdown by generation. Gen Zs having to finance their groceries, going into debt to eat because everything else has become too expensive. So, I don't think I need to. I'm not going to go on and on in this presentation about food prices because we all buy food and we all know it costs a lot of money. But the themes that we see. Sorry if the words are small. You can read them later. But the top left one hand, it's about a topic of there's a patented compound that you can feed cows so they don't fart methane. But there's a lot of health effects. The cows are dying, the cows' fertility rates are plummeting, and we don't know if you eating that cow, if it's going to be, what's the long-term effects on you. But, I think Bill Gates is a funder of that, And that's just an example of the efforts that are being made to reduce emissions from food production. We're seeing this all over the place. Culling of herds. You got to reduce emissions, so that often means you got to get rid of the animals, because they're one of the biggest reasons why global warming is going on is because cows are farting. Sorry, belching, flatulence, whatever you want to call it. So it's a no-brainer. Population is decline. That's the supply. But if population is increasing of humans, which it is, but food availability is going down, it's a no-brainer. It's causing inflation, but they don't care. I don't know why. So the themes today, I'm not going to read them verbatim. I'm going to go back on history a bit. My motivation from all my advocacy in the last couple of years is I love to teach. All throughout university, I taught everything from grade 3 to second university for about 6-7 years, and it's very fulfilling. I believe knowledge is the antidote to what I view groupthink as a disease. As a mental disease, it's extremely dangerous, and we are all guilty of it from time to time. And most of the time, we have no idea. And so these are the topics I'm going to try to focus on today here. I want to remind everybody about this thing called the internal combustion engine, where it came from, what it had an impact on humanity. I want to remind people that it takes energy to make energy. And that's either the sweat of your brow energy or a barrel of oil. And that's the topic I'll move on to. From there, I'll move on to the topic of emissions. Fugitive emissions from a farm versus a marsh up in Fort McMurray. The boreal forest is a massive source of emissions, and very few people ever even think about it. What is our emissions relative to theirs? And then this thing called the Green Revolution. What was it? What were foundational elements that made it possible? And how does net zero look in view of the facts of history? So before I do that, here's just a bit of a background. As Michelle said, I did a stint for about 12 years after I got my doctorate degree at the University of Calgary. I reinvented myself. I had no desire to move to Beijing to work on lithium-ion batteries. Back in the 2000s, there was no jobs here in Canada, still really isn't in that space. And there wasn't much in the United States. So I reinvented myself, got into environmental science. I worked for a consultant firm for a while, and then I landed this killer job in Fort McMurray. Pond 5 reclamation project. It was just, I'm going to have to write a Substack on this here soon, and probably going to write a Western Standard article about it as well. It was probably the largest reclamation project in Canadian history. Over $100 million was spent. And I was part of a team where we learned how to float 10 million tons of geosynthetically reinforced coke, petroleum coke, which is synthetic coal, produced and upgrading on this massive tailings pond. Millions of cubic meters of thin, fine fluid tailings in there. And we were required by the permit, by the Alberta Energy Regulator, get this thing converted to a trafficable surface. And so we developed this technique. And I can't go into it much more, but it was really cool. I was a junior, 1 year out of school, thrown into a position where most people would usually be 15 plus years of project management experience and working with engineers and supply chain and all that kind of stuff. But I was just thrown in there, sink or swim. We got 5,000 other things like this we're doing at the same time. And this was my foray into the oil sands industry. So if I ever sound biased in my writings about how much I love the industry, it's because I know what it did for me. Can't go into the full history of the last 10 years about Justin Trudeau coming, the industry taking a hit, the layoffs, the the project cancellations. We've all been there, don't need to describe it. But for us, my wife and I, who's here in the front row, we saw these storm clouds coming, and there was no more recruiters calling, and finally I took a bullet. In 2020, I got a package. But in 2018, we saw it coming. So we're like, well, I can't get a job doing some of this Dr. Fournier. Maybe I could go back to my blue-collar roots. So when I was a kid, my dad was a bit like John Wayne. My biological father was like a John Wayne, born in the wrong century. Big game outfitter, taxidermist, rancher. And so I had a bit of exposure to that. I always loved animals ever since I was a little boy. I did take a huge vacation from that, going through university and what have you, and corporate life. But back in 2020, I started doing it full time, sink or swim. And it's a bit of a funny farm. A lot of mistakes. But I had a lot to learn. There's a picture of my wife up there. She's learning how to install a big 15-foot cattle gate, putting in underground water lines, power lines. We just started buying animals left, right, hand, and center, and made so many mistakes. The COVID lockdowns were brutal. We had handshakes for like ranch to restaurant deals, but then the restaurants couldn't commit, so we lost tens of thousands of dollars on things. The drought has been brutal. The inflation has been brutal, but we're managing to get the banks paid off, and it's a lot of fun. It's a lot of freedom. It's very uncertain whether Mother Nature is brutal, and I'm learning how to not go bankrupt because of her ups and downs. So now moving on to the meat and potatoes. History of the world. The main thing I'll point out is the global era. 1700, world population, about 600 billion. What happened? It's largely the discovery, widespread use of coal, steam engine. And then from there, oil, gas, so on and so forth. But internal combustion engines and hydrocarbons, without a doubt, we have to remind our friends, our family, our children about this. It's the fact of history. So when I look at this, I feel a great deal of trepidation when I see people talking about the urgency to end the use of fossil fuels and hydrocarbons. So this slide here, picture says 1,000 words. It's pretty clear what I'm trying to say. Medieval era, 4 farmers to produce enough extra food to feed one specialized non-agrarian citizen. It was just so inefficient. The invention of the steam engine, this is the middle one here, is a picture of whole community of farmers coming together. They would throw in a co-op and they would buy themselves a thrasher, right? A thrasher, winnower, steam-powered, coal-powered. That's like the 1850s era. At that point, just that one invention, boom. The productivity, the effect that had on society was just mind-blowing relative to the previous century. Now one farmer could feed 10 people just because of this mechanization and this access to a high energy dense primary energy source. Fast forward to today, the numbers are mind-boggling. My neighbor, I got a view now that I can see like 2 miles, 5 miles, and I can see these monster combines working on the horizon. You just see this plume of dust from like 3 miles away. At nighttime, it's really cool because you can see the headlights all across the horizon going 24/7, pedal to the metal, trying to get the crops off, right? But these combines were so transformative. They call a combine they combine 3 old tools into one. So now one person does the job of 3. The cutting, the thrashing, the winnowing. And the number of people, oh my God. Like, I've got a neighbor, he's got 200 cows, and him and his old man, they manage 2,000 acres of grain. It is, you think of how much food those two men, and that old man works half-time, only during the harvest. The rest of the time, his 40-year-old son manages it all. One person feeding so many. But you want to look at his diesel bill? Right? You know, it's like, it's huge. So that's perfect leeway into this. Here, this is a post-carbon institute. It's an anti-hydrocarbon site. I just went and got this information there. It's readily available in the literature. It's a basic pie chart here. It breaks down the whole food supply chain. And basically, it's what the title says, it 7.5 calories consumed per calorie of food. So 7.5 calories of hydrocarbon energy goes into the entire food supply chain. And that's everything from processing, packaging, food retail, the commercial food services, household food storage, your refrigerator, your freezer, transportation. Well, that's everything. That's from the farming all the way to your table. The farming is a very small subset of that, right? And then if you think about it further, farming, the total energy, well, that's part of that is like, there's some sunlight energy in there too. Right, somewhere in there's some energy that's, right, that's ultimately what you eat. You eat a potato, that's stored sunlight, so that's 1 calorie. But on average, it's like 7.5 times more calories. It's just hydrocarbons. Someone, I watched this TED Talk a while ago, and this guy was talking about how the fact that if you look at a man like me, I'm not as fit as I used to be, but a 200-pound man working 12 hours a day, 6 days a week, consumes food to sustain that level of activity in an agrarian, labor-intensive environment. They consume the equivalent of a barrel of oil, about 6 gigajoules of metabolic energy over a year. You take that person out of food production and you put them in a Starbucks restaurant, a Starbucks coffee shop, or behind a spreadsheet. You have got to replace that with a barrel of oil every year. So as farming, you see where I'm going with this, right? Like the more mechanized we've become, it's required that you consume more hydrocarbons to replace farmers. Yeah, and 85% of all energy used is still hydrocarbons. Sometimes it's 83%, but it's a very common number. So there's a lot of squiggles on this here, and you can study more in detail. Sorry that this one over here has I forgot the references. I got these from the CO2 Coalition, Gregory Wrightstone. I'm a signing member of that group. He sent this one to me, and I'll blame it on him. He cut off the references. It was on the old version. But basically, these plots here represent the history of everything I just finished talking about. So the far left one, you got acres are planted in millions. I believe that's the United States. And the right vertical is grain harvested in bushels per acre, so your yield, right? Productivity. Notice how the red line goes way up, but the amount of land, more or less, stays constant. Like, if you want to talk about sustainability, that is the very definition of sustainability. When you can get more food, more energy out of the same amount of land, that's a win-win story. That's mechanization. That's the green revolution. CO2 emissions, well, that's just a measure of the replacement of humans with a barrel of oil. Same information, more or less, is being shown here on the right-hand side. This is from 1960 to present, so that really is the green revolution, and that's everything from nitrogen fertilizers, GMOs, and like genetically modified foods, and herbicides. And that's those topics, especially the last one, herbicides, Roundup. You know, it's a very contentious topic today. And there's a lot of people talking about we need to do this, we need to do that, we got to like stomp it out. It's such a complex story. The stakes are very high. If we get it wrong, we potentially upset this trend and people starve, inflation, right? So this one here I include, this is a topic that's a lot of fun for people like myself or like Ronald, is the idea that the atmosphere, as it becomes warmer and more enriched in carbon dioxide, plants thrive and they're more productive. So this is a plot from the University of Oklahoma, and it's just common net photosynthetic rate on the vertical axis, leaf temperature on the x. The black is like an ambient CO2 concentration, like say 400 parts per million. The blue is where they jack it up to like 2,000, 1,700. The shift goes up and to the right. Plants crave warmer temperatures as the CO2 goes up. That's one of the things it tells you. And obviously, its photosynthetic rate shoots through the roof. There's a limit to that. It's usually around 1,700. It varies for different types of plants and different types of metabolic processes from one species to another. But it's a very, very important story that people have to be reminded about. Michelle said you need a break here. It's a good picture, too. Switching gears, and we start talking about emissions. Ours versus Mother Nature. One thing that really gets me going is stuff like this. Because we always talk about emissions. And then the assumption is always that it's only a cost. And it's only a negative. You know, like, so this year's a breakdown: oil and gas, transportation, buildings, heavy industry, agriculture. And then for agriculture, you can see it breaks it down: on-farm fuel use, crop production, and animal production. What they don't tell you at the same time, though, is that Canadian grain farmers produce enough calories to support a population 6 to 10 times Canada's population. 6 to 7. I just did a quick query. Tons of grain produced, average calorie density, you know, just did some rough math. And these emissions produce this effect. Our farmers, which are only about 1% of our population in Canada, produces enough food to feed, enough calories to sustain over 300 million plus humans because of hydrocarbons, because of tractors, great big diesel engines, right? Like that's the raw effects that are hidden from people when they see stuff like this. But because we're so disconnected these days, and the downside to mechanization is that so few people know anything anymore about food production. Just like we don't know much about a lot of things like logging and fisheries and all that kind of stuff, right? We're so disconnected. Similarly, Canadian oil and gas our production is enough to supply 2 Canadas, right? Very productive. This time series from Stats Canada is for agriculture. The color coding, hopefully you can see at the top, is on farm fuel use, so like diesel, gas. Crop production is the middle band, animal production is the bottom. So animal production, that's burping and farting. Crop production, that's like residue that you leave in the field and it rots and it turns back to gas or it turns back to soil, bit of both. The reduction in animal production, that's the mad cow outbreak. Right around that time, there was a peak in the population of these 14.5 million cows in Canada, and shortly thereafter, there was a major culling, and ranchers were decimated. They were desperate for prices to go up again. They had a lot of aging out cows because they couldn't sell them. Population, anyway, so there's a cull, and it was an attempt to jack up the prices again. So that's why animal production went down. Take note of that. Of this history here, the biggest reduction was not due to anything other than culling off millions of cows. So this plot here on the left this breaks down further the on a percent basis. Just the numbers aren't showing, but you can roughly see that approximately half of what we refer to as agricultural emissions is just belching and flatulence. Okay? A very small fraction is fuel use. Look how small that is. The rest is all natural processes. Crop residue. So when I start thinking about these things, I was like, well, what's the difference between a bison and a cow? Right? Like, what's the difference between if a termite is converting cellulosic material to methane? That's predominantly what they do, right? So why do we have this bias? Why do we accept this storyline continuously, that there's something negative about a cow or a goat or a sheep, but it's anything that we got our hands on? That's one thing. I don't have a slide for this next thought, but it came to me tonight. I was thinking about it. It's like the other very bizarre, illogical thing that I find is that it's okay to take corn, convert it to ethanol, and burn that. That's not an emission. It's an offset. I can take canola and I can push it through a refinery and produce drop-in diesel. And that's an offset. But if I take that corn and feed it to my cow and it farts it out, that's an emission. So I don't make the rules. There's some I'm obviously missing something. I don't know what it is yet. I'm looking for an answer. So I love that one, right? Global warming. That's a dairy cow. I love dairy cows. I also love that picture. In my DNA, I wish, I'm a conservationist. I like my dad. I wish I'd love to live, just run away and never come back. When I was a child, I wanted to go be a mountain man. But then I'm also an extrovert, and that's very lonely. So I'm glad I didn't ever do that, and I would never have met my lovely wife. So that is, as beautiful as that is, it is a massive emission source, right? There's a reason. That's a bog. That's a wetland. If you were to walk out into there, if anybody's walked or try to walk into a pond like that, you'd be lucky if you don't sink up to this much in muck, right? Just slop, organic material that bacteria are breaking down, and there's bubbles coming up, and it stinks, and it's rotting vegetation, not unlike a cow's behind. Now, one of the things these graphs down the bottom, this one here in the middle, that's a methane, that's a representative of a global methane concentration time series. Measured from 1985 to the basically present. You notice this. It's not like this, right? Human population over that time frame has done that. The amount of rice paddies, the amount of cornfields, the amount of nitrogen fertilizers used has done that. When you take a first derivative of that, or the annual rate of change, that's what the rate of change looks like, the bottom right. Something happened. Don't know what it is. Something happened around the turn of the century where suddenly the atmosphere methane concentration stopped changing. So we're told all the time that we are the primary reason for the out of balance atmosphere. If there's a change occurring in it, in its composition, it's because of us. Too much of this, too much of that, greedy capitalism. But I refuse to believe that. I've actually, in my research career, I actually had the pleasure of doing a lot of work on emissions quantification. I even worked with a team of scientists that came to my group at Suncor because they were looking for funding and collaboration to design a satellite that was to launch shortly thereafter to measure CO2 emissions. And I was sent into this group to work with these scientists because I had one of the few scientists at Suncor at the time who had strong emissions background. So I know a thing or two about this topic, and I'll do my best to make it really clear. So this slide here, now I want to try to start moving in the direction of answering the question of how much does Mother Nature do versus us? Okay, so let's start with Alberta first. So I'm going to take you on a bit of a journey here. I've done some reading and writing and arithmetic on this. I published it on my Substack, Western Standard, and I would love, absolutely love to have a public debate with the best scientists coming out of Alberta Environment or in our energy regulator to challenge them on some things. We're going to get into that now. So this bottom right picture, this is a method. It's a rudimentary, cheap method that most academics or consultants use is to measure the fugitive emissions from a surface. In this case, you could measure the fugitive emissions coming out of your lawn. So it just basically, it's put this container on a surface and stopwatch. And you capture the gases coming out, and then you measure, and you take that, the area, the time, and the concentration of the gases that you measure, and you come up with an emission rate. Mass per unit, time per unit area. That's a flux, an emission rate. So that is a rudimentary, it's highly accurate, but it's very small, right? The Earth is huge. Now, my apologies if this is not very clear. I'm going to walk over here. So this figure here is from I did a literature review for a professor last year. He wanted me to educate him on some stuff when it came to methane emissions. So I did this. This is from this literature review I did for him. This basically, it talks about this image, 3 different modes of methane emissions, fugitive emissions from a wetland. A flux chamber only gets diffusion. That's just your steady release of bug gases, right? Methane, the emissions, by the way, occurs when oxygen levels are low, right? It's an anaerobic, anoxic environment. CO2 is produced by soil bacteria or wetland bacteria when oxygen levels are higher. When methane is being emitted, it means you're forming humic materials, peat. When you're seeing CO2 coming out, it means you're losing peat. It's deep oxidation. You're losing organic content in your soil. That's just another principle. The flux chamber catches diffusion, but it doesn't get it doesn't capture this event called ebullition. And that's when, imagine a big gust of wind comes in, or a Chinook comes and goes, and there's a sudden change, perturbation in pressure, or near pressure, change in the low pressure zone forming on the surface, can cause bubbles that start to develop deep inside the muck, and these bubbles will suddenly get perturbed and they'll release. It's not constant. Diffusion is constant, ebullition is episodic. Ebullition is, in the literature, is commonly said to be much more significant than diffusion. But it's very hard to capture it because you don't know when it's going to happen. It's episodic. The other is called diffusion through Hiroshima. That's like specialized gas exchange tissues. A lot of wetland plants and trees, their roots need to breathe, right? And so the plant is, but the muck is so anoxic, anaerobic, very low in oxygen. So a lot of wetland plants have developed special gas exchange tissues that allow diffusion of air down and metabolic waste out. But all the microbes that live off of those roots and the sugars and that ecosystem at root depth, also their farts go into the tissue and then goes up like chimneys. The higher the plant, the greater the pull. And so that mechanism likewise can't be captured using flux chambers. So all that being said, flux chambers, while they're very accurate, they are the lowest estimate physically possible. But we like the number because it's so accurate. Low error bars, and you can trust the numbers you're getting. But you know that you're missing all of this other stuff. We can't put a flux chamber on a shrub, right? You need to put a greenhouse around that thing, and that costs a lot of money, and PhD students are really lazy. So now that I covered that, and I'll move on to this. This is an Alberta Energy Regulator update from this last year. It's on the left-hand axis is the methane emission reduction for the provincial oil and gas industry in terms of CO2 equivalent tons per year. So you can see for 2014 to like 2022, it's dropped significantly. The regulations, the people involved, everybody did a good job. They did what they were told because they were required by law. Now, I've done some literature analysis. I've looked up the best flux chamber data I could find for the boreal forest specific to the oil sands region. And it's mostly, if you've been up there, it's mostly bog. It's a very unforgiving territory to try to ever walk through. It's impenetrable. But there is data, and there's been a lot of research. And the flux chamber data that I've seen, when I compare it with this, the Alberta Biodiversity Monitoring Institute, we've actually got satellite data. We know how many square kilometers there is of muskeg, swamp, all the different types, bog, fen, marsh, open water, in different types. They've got it all, square kilometers for the entire province. I actually found data to average flux data for these different types of wetlands. It was a bit of a gold mine that I had discovered. It took some time, but I found it. So I just did the math. I had flux times by area over a year, and I come up with an emission. Mother Nature's emission from just Alberta bogs. And there's error bars because Mother Nature's always exposed to changing environment. We get a lot of precipitation, the water table rises, emissions rise. You get more methane when the water table is high. When the water table drops, it's droughty, and more oxygen gets into the peat, and it burns off through metabolic processes, releases CO2 versus methane. So that's why there's a huge range. But that's just flux chambers. And you can see here methane emissions on the right, because it's not CO2, it's methane. They're basically on par. If I times that right-hand axis by what we call a global warming potential factor for methane converted into what it would have an equivalent global warming effect to CO2, they're on par, meaning the methane emissions from Alberta's bogs are on par with what the oil and gas is reporting they're emitting through leaky valves, loose union joints, flaring events that didn't quite go right, that kind of thing. But again, this is the minimum. If I included diffusion through erythema tissue, if I include ebullition, it would actually be multiple times higher. We don't know what it is. It could be as high as 10 times higher. So massive uncertainty, but the best available numbers shows they're equivalent. So that's just Alberta. Now what about the area of peatlands from Manitoba to Alberta across the north. Again, you know we know what these numbers are. What about the whole country? The bogs in Alberta are big, but not. Canada's a huge country. So you start extrapolating this out using these literature values, both for Alberta as well as for other northern water ecosystems. It's very clear that Mother Nature dominates. And the most conservative estimate that we can make using flux chambers shows that we're equivalent. Mother Nature is like 10 times higher, minimum of 10 times higher than emissions from all the ag sector, or 10 times higher than the emissions from oil and gas, methane emissions, methane, okay? Remember I said that. I'm not talking about CO2. That's a different number. We're not talking about CO2, we're talking about methane, because we're talking about cow farts. Changing the topic now. So I'm moving to the Green Revolution. The Haber-Bosch process. A German chemist, German engineer, early 1928 or something like that, or no, 1918, somewhere in that time frame. It was right around World War I. And the Germans were needing sodium nitrite for explosives. And they were having to haul it in from Peru's guano mines. And they were running out. And wartime efforts were like, supply chains were in doubt and all that. So hey, let's make a synthetic reduced nitrogen. So the Haber-Bosch, the name of the two scientists, they came up with this little equation here. Nitrogen, atmospheric nitrogen, 3 hydrogens under the right intense high temperature pressure conditions, you can form ammonia. Pardon me. The source of the hydrogen is coal or natural gas. 99.9% of all nitrogen fertilizers are created using hydrogen from natural gas and coal. In North America, it's coal. It's natural gas because we got so much of it and it's so cheap. We're extremely blessed for that reason. China, the largest producer of nitrogen fertilizer in the world, and they're not fortunate like us. But they have a lot of coal. So they produce copious, like 30 million tons a year of nitrogen fertilizers from coal. This shows here around the top of the United States and Italy is corn yields on the vertical axis, is tons per hectare. Time on the y-axis showing the different countries. You can just see the explosive growth in yield, productivity. That's a massive, massive boost. Corn is especially, they're not all like this, and not all regions are as successful at this as the Americans and the Italians, obviously. They're doing something else. But this is not just nitrogen, okay? There is mechanization changes, there is herbicide, there is GMOs at work, all these things, but the literature is very clear on this estimate, the one I have in the bottom. 50% of humanity would starve within 1 to 3 years if you suddenly shut off every Haber-Bosch fertilizer plant on planet Earth, because productivities would plummet so fast. And the reason why they plummet, every time you take a potato out of your garden, you got to replace the nutrients that you removed from it. So you look back in the day, nomadic tribes, bison, they would eat, drop it behind, then move on. They're not shipping it from Alberta to China, right? So whenever you take something from a field, you have to replace it. It's money. It's lost nutrients. So that's why you really need to have nitrogen. Nitrogen is where you build your amino acids. That's where you build your deoxyribonucleic acids, your ribonucleic acids, your genetic information. It's all built on a building block of nitrogen. The currency of life, another fancy molecule, adenine triphosphate. That's the currency of every single living organism on God's green earth, as a plant or an elephant. Is used at its base is reduced nitrogen. So that's why productivity goes up so fast when you make reduced nitrogen available. So this is the nitrogen cycle, and you don't know how hard I had to look to find an unadulterated nitrogen cycle illustration. Every single one has a dairy cow in it. Right? The imagery is so consistent. Every child that ever learns the nitrogen cycle, they learn it through the lens that humans have altered this natural cycle. And nitrogen is just one of them. The other one is obviously carbon. But it's the same thing with nitrogen. We've altered these cycles, and we have. We don't know by how much, because you can't quantify atmospheric deposition. A lightning strike happens, rips open nitrogen and oxygen, and a nitrate falls on the surface. It goes through a bunch of metabolic processes in the soil and the plants, and then it gets burped back up as N2, and it starts all over again. We can't measure that rate. We can estimate them and then extrapolate them, but we really don't know with any accuracy. But we do know very well how many tons of ammonium nitrate or urea we sell on the global markets. It's because it's one of the most commonly sold commodities in the food space. So the pros: productivities. Deforestation rates have, across the middle latitudes for the last 60 years, has just flatlined, while productivities of yields have gone way up. So we've preserved, there's a lot of regions, like in the United States. I saw this image the other day. I should have put it in here, but it shows just since the Green Revolution how much forest is actually in the Appalachians, how much forest has grown while their food production has exploded. So virtually limited need for summer fallow. We're going into that now. A lot of you guys, there's a little bit more gray hair in this room than I do, so probably a lot of you remember fallow fields here in Alberta. You don't see them anymore. The cooling effect. As you jack up photosynthesis, you are cooling the environment, because that's an endothermic process. It takes heat, and there's more vapor, water vapor, going up through the tissue and out into the atmosphere. So it's called, and it's more latent heat. Cooling is a cooling effect from the sum total of those processes. When that energy comes down, it either goes into one of two things. Either goes into evaporation and photosynthesis, or it goes into increasing the temperature of the surface or gases. So plants do more. The cooling effect is less going into temperature and more going into chemical bonds. So that's a very important thing. And nitrogen has done that. So right, you see where I'm going with this, right? The counter narrative is very easy to spin if you actually step back for a moment and you actually start to look at things through objectively. It's still science, but it's alternative. It's an alternative truth, I guess. Alternative fact. Increased drought resistance. This is so important. You see it in alfalfa, all the legumes, plants that can fix nitrogen in their roots. They are the very, very last plant type to go brown during a drought or at the end of the season. It's just the way it works. The more nitrogen you've got, the stronger you are, the more water efficient you are. And I believe full-heartedly that we are expanding the biosphere. Just go down Policeman Flats. If any of you are fly fishermen, been down there, Policeman Flats versus upstream of Calgary. We've got one of the best water treatment plants in North America here in Calgary, but we still send out a lot of nitrogen and a lot of phosphate. You look at the productivity downstream versus upstream, there's a reason why world-class fishermen come here. They don't fish upstream near as much as they do down. Right? We're expanding the productivity of the biosphere. Every time you drive to Edmonton, even with your catalytic converter, your NOx is going up in the atmosphere and you're fertilizing fields as you go up north. Right? So you're accelerating productivity of Mother Earth. Every time you throw some nitrogen oxides out your tailpipe. So no-till. When I was a kid, I bumped this thing. Hopefully it's working well. When I was a kid, it was very common. I do recall seeing a lot of fields driving by with my grandfather up in Lloydminster country and seeing so many fields that were, Grandpa, why? There's nothing in there. Why are they, it's like July, why are out they tilling that field? Oh, that field's in fallow. We will revisit that field at least once, sometimes twice in a season, because you got to kill the the weeds that are forming. So they'll go out there and they'll till the ground to kill the weeds while it's going fallow. And what a field does when it rests, it receives nitrates from the atmosphere. That's the number one thing. Naturally occurring rates of nitrogen fixation through lightning strikes, particularly, is happening, and they fall either with rain events, where the rain really clears out the atmosphere and cleans it up, drops it on the ground. That's called wet deposition or dry deposition. So that's what happens during fallow. It's about replenishing your nitrogen. And back in the day, not too long ago, even up to the 80s, upwards of 20 to 50% of the farmland in Alberta would be in fallow. Nitrogen fertilizers came along, and you didn't have to do that anymore. Herbicides came along, and you didn't have to till that field once or twice a year. Tilling is very bad. It's very hard on the soil. It's a living organism. And when you rip a plow through it, it's massively disruptive. And if you do it enough, you'll kill it. Downsides. Yeah, downsides. So one of the downsides with tilling is that you're oxygenating the soil. You're seeing more CO2 generation versus methane. The water table is dropping every single time. The moisture content is dropping every single time you do it. But farmers have had no choice up until just the Green Revolution. They had to go fallow. If they don't, they'll kill their land. The 1930s Dust Bowl is where our farmers in this region, yes, the North American prairie farmers particularly, as well as in Ukraine, the Holodomor, that massive famine was partially due to about 2 or 3 years around that middle latitude range in the northern hemisphere, where precipitation was in extremely short supply. But what happened was, because they were doing this fallow techniques, letting fields go fallow and then going out their plows and plowing them multiple times, they destroyed the root structure. And root structure in soil holds the aggregates in place. So so when a drought comes in it, and there's no moisture in the soil, those roots, the only thing that's holding that powder from blowing away in the wind. And that's why you see pictures like this from the dirty 30s. Interesting point. My neighborhood, we've got a lot of families that are going 4th-generation families. They showed up in like some of them 1895 to 1910 period in the Rocky Ford area. Some of the people I talked to, they've told me that the drought we've been going through off and on the last 3 years, particularly since I moved out there. Some of them actually joke saying I brought it, but you know, it's comparable. But we haven't seen a drop in yields. Nothing like this. It was comparable to the Dust Bowl event, but yields have not dropped, and there's been almost no erosion. And it's because of the fact that we don't do fallowing, no fallow, and no tilling. So there's a terminology, no-till farming. It means just that. They don't disc it. It's farmers, the current generation of farmers, they've just like, they're so excited about what they have seen from over the last generation of knowledge that's gained on soil science and on how to engineer drought resilience. These guys have been doing it before it became fashionable on social media. Don't get me started on that. But so here's a picture of an air drill seeder and a big tractor. That's like a $1.5 million setup, by the way. So air drill seeding, that's what they do. And instead of plowing it, they got a little, like a pizza cutter, and they shoot, boom, close. They shoot their seed into the ground with a pneumatic. And you notice that there's hardly any change in color between he's right ahead of the tractor versus behind the tractor. They've hardly disturbed the surface. And something that I've really learned I'm not a farmer, I'm a rancher. I have learned over the last few years the hard way the importance of soil armor, color. A light color reflects sunlight. Exposed soil warms up so much faster because it's black, right? So keeping that residue, that farming residue on the surface is the armor that preserves soil moisture for the next year. After a harvest, a farmer does not want to bale. If they bale, they got to fertilize the next year because they've taken all that nutrient off that farm and they've lost all that armor. A lot of times they have to bale because the yields are really high and they got way too much organic residue left on the surface that those air drill seeders can't cut through. And so it's a good problem because now you can sell that bale for $40 or $60, whatever it is, but you still got to fertilize the next year. But this no-till farming, I don't have the data here yet. I'll be writing about it and publishing on it more in the next little while, but the other thing that it does in addition to preserving soil moisture is it allows your soil to preserve your root structure. You don't rip it up. You don't oxygenate the soil. And as a result, by leaving all this litter on the surface and allowing those roots to just build up every crop to the next, your carbon content has the potential to grow. They're actually sequestering carbon, and there's an ongoing debate as to, is that effective? Can we make money off that? But aside from the credits, I like to give credit to the ingenuity of the industry. It's generations of knowledge, and hardship, blood, sweat, tears, starvation. Like when you start to look at from the Great Depression to now, the stories that you hear it's the stories of people's lives, and the Great Depression was such a turning point for the prairie farmers in North America. So conclusions, and I'm doing pretty good. Wow, I thought I would go overboard. I could say a lot, but if you ask me, the most important things that I want to leave you with here today, please, if there's somebody who I offend, please don't throw anything at me. But I believe that villainizing CO2 and methane emissions from food production, net zero policies are by design inflationary. And I try to emphasize that more and more these days because the average person now is starting to understand what that word means. 20 years ago, only people who cared about inflation was boring economists writing PhD dissertations or the Bank of Canada. But now the average person, even kids, are they know what that word means. Net zero, as far as I'm concerned, energy transition, they are all reducing nitrogen fertilizer to reduce the amount of emissions of N2O. N2O is a greenhouse gas. They're saying we need to reduce nitrogen fertilizer use by 30%. Okay, I don't need to go down that path. Repeating everything I've said to you guys tonight, but it's inflationary. Because there's no alternative. You either will starve people, or you'll bankrupt them. Probably both, one in particular order. The second point, food production in the 21st century is intimately dependent on hydrocarbons. Every person you take away from a field, you replace with a barrel of oil. And there's no technology out there that can run that great big monster tractor other than diesel. Internal combustion there's nothing, not even remotely. Batteries, you can't put I'll go back to this picture here. Notice the tracks on that. Manfred, why is that? Why is there tracks on that tractor? Take a guess. Versus tires. Exactly. Snowshoe effect. Exactly. Compaction is horrible. You destroy your soil. A rain will come along and it will just run off of a compacted surface. So that tractor is already huge, and look how much effort they're putting to distribute that weight. You want to replace that little tiny diesel tank with a monster battery fuel cell pack, like a battery pack. It's like an order of magnitude more weight between that diesel tank and a battery pack. You cannot put that in a tractor. You will destroy that field, and that farmer will chase you away with a shotgun. In closing, it's a good point for a little bit of a story. I made that mistake really. In my first year, I moved out, didn't know anybody, and I had a semi drive into my feedlot, and it got stuck. And I was trying to pull it out, but it got stuck in a laneway between my property and my neighbor's property. And it was around 7 o'clock at night. The sun was setting. This guy needed to get back up to Hinton. Long drive ahead of him. So I'm like, how do I get him out? I tried to pull him. I couldn't. I got a little 75-horse, tiny little acreage tractor. And he's got 30,000 pounds of, and he was fully loaded. He's stuck deep. So I had to come up beside him and start lifting the bales off. But as I did that, I had to back onto my neighbor's field. It had been harvested. This was in October after the harvest. And I was rutting out a little bit. Not too bad. But I forgot to cover my tracks. And this is how I met my neighbor. We're good friends now, but he was pissed off. It's like a cardinal rule. Not even trespassing. It's you're compacting my soil. You don't do that. You got to ask for permission. You pick up the phone and call me. Sorry, I didn't have your phone number. I didn't even know your name. But anyways, that's it. Questions? Thank you very much.